Okay, so this is the application of the information that I presented in the previous recording. So if you haven't listened to the previous recording about how organisms, how we determine how related they are and how we make these trees, you may want to listen to that first. But this is the application of that information, the kind of questions that you could be asked on a test or quiz. So first, let's look at this. Taxon A is more closely related to C than B. So we're looking at A in this cladogram here. And we're assuming these numbers represent, let's just say, traits that appeared throughout evolution. So these numbers are traits. And we want to know, is true or false, is A more closely related to C than B? So the way that you do this, you track them back. So if I track A to B, I hit 5. That is the most recent trait the two of them share. And now if I switch colors and I track A to C, I see that I have to go all the way back to trait 3 before A and C actually share a trait. So this would be false. A would not be more closely related to C. A would be more closely related to B. Let's try the second one. So D is more closely related to F than to C. So let's pick a color here, and let's do D. And actually, I could just track it all the way back. And then F versus C. So let's do F first. F, notice that they hit at 4. And then if I do C, here they hit back at 1. So D is more closely related to F. That is true because it hits 4 before it goes back and hits 1. Next, G is more closely related to H than to E. So let's take a look at that one. So let's do G first. So again, I can track this all the way back. H, so G and H hit at 9. And now we want to look at E. And E, if I track back, they hit at 7. So this would be false. And this is a really good example because some people were getting this one wrong in class because they were looking at the number of events that happened and thinking that G and H must be more closely related because there's less events afterwards. But the events afterwards don't matter. It's how far back do you have to go before they connect. And that's what's really important. The last one, C is more closely related to F than H. So we take C all the way back. We take F all the way up. Well, here we go. So F, it hits at 1. And then H, color here, and H hits back at 9. So is C more closely related to F? Yes, it is. So that would be true. So those answers should have been, let's see, false, true, just a heads up on that. So another thing that you will have to be able to do on the quiz that we're going to take on this is you could be asked a question like this. Name all the traits that are shared by, let's just say, A and C. So again, to figure out all the traits they share, if I track back, I see that A has traits 3 and 5. I'll pick a different color. If I track back C, C has 1, 7, 9, and 3. But notice that the only place where the two of those cross is 3. So that would be the only trait that is actually shared by both A and C. Now let's try one more. What traits are shared by C and E? So I already have C there. Let me draw in E with a different color. I should use the highlighter, but that's okay. And I see that C and E cross at 1, 7, 9, and 3. So 1, 7, 9, and 3 would all be traits that are shared by C and E. So that's how you would figure out what traits are shared. Any place where their two lines intersect, that would be traits that are shared. All right, the second section, the other thing we talked about in the previous lecture, was what a clade was. So a clade is a branch that starts with an ancestor and includes everything after it. So first question, do C, D, E, and F form a clade? So I'm going to highlight them. The first thing is, do they all track back to one ancestor? And they do. C, D, E, and F all track back to 5. So it meets that first requirement. Second requirement, is everything after the point they meet highlighted? Yes, it is. After 5, we've highlighted every single organism, and therefore, yes, that would be a clade. Now let's look at the second one, F, G, and H. So here's F, G, and H, and we want to know if they form a clade. Erase this over here. All right, so if I track them back, H tracks all the way back to 7. G, well, technically G also tracks to 7 and F tracks to 7, but if I'm going all the way back to 7, is everything after that point highlighted? And it's not. I've left out all these organisms. So that would not be a valid clade, because if whatever it tracks back to, wherever they converge, you would have to have highlighted everything after that point. So that would not be a valid clade. A and B, do they form a clade? Yes, they do. We look at A and B and we track them back. We see that A and B meet right here at trait 9, and everything after that point is highlighted. So yes, that would be a clade. And then our last one is A, B, C, D, E, and F. So if we highlight those, A, B, C, D, E, F, and track them back, do they all track back to one point? Yes, they do. They track back to 1, but here's the problem. Once we track back to 1, actually technically once we track back to 3, we need to include G. So that would not be a valid clade. So this should have been yes, no, yes, no. All right. The last section is a little more practice of the same thing. Which are more closely related, C and V or C and Q? So again, we track back C and V. We track them back, and they would track back here to 6. That would be the last trait that C and V both share. C and Q track back further. You have to go all the way back to 8. That's the last trait that C and Q both share. So your answer here would be C and V. Next, which one is most closely related to A? So if we look at A and I track back, the most closely related would be H, because that would be right here and tracking back just to 2. So this would be H. This was C and V. Which one, Q or H, is more closely related to V? All right, so we're going to start with V and track back, and I can see, let's see where it hits Q. It hits Q at 8. And if I want to track back where it hits H, looks like I have to go all the way back to 4 here. And therefore, V would be more closely related to Q. And then number 4, which are more closely related, C and E or C and S? Now, I really like this one because it really makes you think. C and E and C and S. So if I track back C and E, and see how far back we have to go, C and E track back to 6. That is the most recent thing they share. And guess what? C and S also track back to 6. So technically, these are equally related. This would be equal. So one is not more closely related than the other. If the last trait they share, C and E, is that one, and C and S also. And again, this is where some people would mess up because they think maybe C and E because they're closer looking at the top, or sometimes they think, oh, C and S because there's all these changes after. None of those things matter. They all track back to 6 as their last shared characteristic. They're equally related. And then finally, which one, H or L, is closer related to K? So let's take a look at K first. Get rid of all this. Okay, so here's K right here. And they want to know H or L. So L and K track back to 1. That's their most recent trait. And then K and H here track back to 7. So your answer would be K and H. Those would be the more closely related, not K and L. You have to go further back to connect K and L than you do to connect K and H. So hopefully this little practice sorts out any issues that you might be having. And again, you could be asked questions about relationships. I'll throw one more of those in there. If I said, hey, what traits are shared by, let's say, A and S? What are all the traits shared by A and S? Well, if you track back S, and then I use a different color and I track back A, your answer would be the only trait they share would be 4. On the other hand, if I said, what about X and K? X and K. Let me erase everything here. So X and K, track X all the way back, track K all the way back, and X and K would share 7, 1, and 4. Now, if you were asked what's the most recent trait they share, it would be 7. But if you were asked what are all the traits shared by them, it would be 7, 1, and 4. Everything that both lines hit. So hopefully that helps you. In my next explanation, the last one for this little chapter, we're going to learn how to do one of these. We're going to learn how to take a matrix and turn it into a cladogram. So make sure you watch the next lecture to learn how to do that. That'll also be on the quiz that we're going to take on this. And then you should be good for taxonomy, and we'll be moving on.